exploring the strengths and limitations of AI, and the challenges and prospects of achieving artificial general intelligence, AGI.
AI has made significant advancements, leading many to believe that it will soon surpass human intelligence. However, can AI actually achieve this level of intelligence?
That's right. The belief that AI will become smarter than humans is based on the assumption that AI can not only improve itself, but also expand its capabilities beyond any inherent limits. The current question is not whether AI is already smarter than humans, but whether it has the potential to become smarter.
Exactly. While there may be a future AI that can surpass human intelligence, generative AI is not capable of achieving this. The current AI technology is not only not smarter than humans, but it also cannot improve itself to reach that level of intelligence.
And this argument is based on fundamental conceptual limitations on types of reasoning. In other words, there are certain limitations to how AI can reason and think. This is important because it helps us understand what current AI can do and what would need to be done to create true artificial general intelligence, AGI.
The article then takes us back to the history of AI, specifically the 1950s to the 1970s, when deductive AI was prominent. Deductive AI focused on using known rules to deduce new knowledge from known facts. It involved theorem proving, game playing, machine translation, general problem solving, and conversation.
Right. Deduction is a way to create new knowledge. It takes existing truths and uses known rules to produce new truths or certainties. For example, if we know that all men are human and Socrates is a man, then it logically follows that Socrates must be human. Deduction is about exploring the consequences of accepted rules and axioms.
That's a great example. Deductive AI was successful in solving problems by applying known rules to known facts. Whether it was a game of checkers or translating languages, deduction was relatively easy to program. The challenge came in determining which rule to apply and whether it moved you closer to the goal.
And while deductive AI had its successes, it also had its limitations. For instance, machine translation struggled with the ambiguity of language. Language has too much nuance and multiple meanings, making it difficult to deduce the exact meaning. But overall, deductive AI showed promise, especially in areas like expert systems that could significantly improve efficiency.
However, progress in deductive artificial intelligence started to slow down towards the late 1970s. The improvements relied more on increased computing speeds rather than fundamentally new techniques. Deductive artificial intelligence had its limitations, and it never reached human-level intelligence. This led to a decline in funding and what was known as the AI winter in the 1980s and 1990s.
That's right. Deductive AI reached its inherent limits, just like any other technology. Every technology has its bounds, and once those limits are reached, the rate of improvement starts to level out. So while AI may have seemed exponential in its growth, it eventually plateaued.
And this brings us back to the question posed earlier, can AI become smarter than humans? Generative AI, as it currently exists, is not the answer. It doesn't have the capability to improve itself beyond the limits set by human intelligence.
Absolutely. The limitations on types of reasoning and the plateauing of progress in deductive AI highlight the need for new approaches to create true AGI. It's not just about making small advancements or improvements in current AI technology, but rather a need for a breakthrough that can transcend the limitations we currently face.
In the next section, we delve deeper into the evolution of AI and the challenges it faces.
Now let's shift focus to the concept of induction and its relevance in AI. Induction is the process of creating rules based on known facts, which can then be used to infer new facts. While deduction guarantees the truth of new facts, induction only provides likelihood.
That's right. Induction is incredibly useful, especially when there is a constant mechanism generating the future. For example, ancient civilizations observed the sun rising every day and assumed it would continue to do so, even without knowing the underlying reasons. Induction allows us to make predictions based on existing knowledge, even with imperfect understanding.
Absolutely. And in AI, induction has been used since the early days. However, it wasn't very effective initially. During the AI winter, researchers started distancing themselves from AI and instead called their inductive reasoning systems anything but artificial intelligence. One example of early inductive learning was Firefly, a music recommendation system that learned from user data to make personalized suggestions.
Firefly collected information about users' music preferences and found connections between different artists. If people who liked Guided by Voices and the Beatles also tended to like Neutral Milk Hotel, Firefly would recommend Neutral Milk Hotel to someone who liked the former too. It learned these linkages without understanding why they existed. This kind of recommendation system is much closer to human intelligence than deductive reasoning, yet it wasn't recognized as AI.
It's interesting how we consider certain tasks as signs of intelligence when humans do them naturally. But when computers perform the same tasks through induction, we don't view it as true intelligence. There's an irony there.
Definitely, and Firefly became successful because it emerged during a time when the internet was widely accessible and data could be easily collected. Unlike expert systems of the 1980s that relied on curated data, Firefly used real-world data and statistical techniques to make predictions. And as more data became available, the predictiveness of these techniques grew exponentially.
That's right. And it's worth noting that there were many influential inductive AI programs during that time, although they were not formally recognized as such. They were referred to as machine learning, deep learning, or big data. Critics often dismiss machine learning as just statistics, but this overlooks the power of induction. Statistics allows us to infer relationships between incomplete facts and use those relationships to predict the future.
Exactly. Statistics and other inductive techniques are like magic in their ability to extract meaning from messy data and make accurate predictions. So it's important to appreciate the significance of induction in AI and not treat it as a lesser form of intelligence. In this final section, we'll discuss the future of AI and the quest for artificial general intelligence, AGI. AGI refers to AI that can perform any intellectual task that a human being can do.
Recent advancements in AI have focused on deep learning, neural networks, and big data. These developments have enabled machines to perform specialized tasks with impressive accuracy, such as image recognition and natural language processing. However, these advancements are still far from achieving true AGI.
Absolutely. While deep learning and neural networks have revolutionized certain areas of AI, they are still limited in their ability to generalize knowledge across different domains. They are highly specialized and lack the holistic understanding and adaptability of human intelligence.
That's where the concept of generalization comes into play. Human intelligence has the remarkable ability to generalize knowledge and apply it to different situations. We can learn from one experience and transfer that knowledge to a completely unrelated context.
Right. And achieving true AGI requires capturing this ability for generalization. It involves creating AI systems that can learn from experience and apply that knowledge to new and unfamiliar situations. This means going beyond traditional statistical learning and exploring new approaches that can emulate human-like understanding and reasoning.
Absolutely. And this is where the field of inductive AI becomes relevant again. Inductive reasoning, with its ability to create rules based on known facts, provides a foundation for building AI systems capable of generalization. By creating models that can understand and infer relationships between different data points, we can move closer to achieving true AGI.
However, the path to AGI is not without challenges. The limitations of current AI technologies, such as their lack of common sense reasoning and inability to handle ambiguity.
Common sense reasoning, which comes naturally to humans, is still a major hurdle for AI systems. Machines struggle to understand context, interpret subtle nuances, and make intuitive judgments. Overcoming these challenges requires not only advancements in technology, but also a deeper understanding of human cognition.
And it's important to recognize that achieving AGI is not just about creating more powerful hardware or improving algorithms. It requires interdisciplinary collaboration, bringing together experts from various fields such as computer science, neuroscience, psychology, and philosophy.
Absolutely. The development of AGI requires a holistic approach that combines technical expertise with a deep understanding of human intelligence. Only by bridging these disciplines can we hope to make significant progress towards building AI systems that truly emulate human-like intelligence.
And that brings us to the end of our discussion. We've explored the evolution of AI, the role of induction in AI systems, and the challenges and prospects of achieving AGI. It's a complex and fascinating field that continues to evolve rapidly.
Will humanity achieve true AI intelligence in our lifetime? Click here for part 2 as we search for answers.